Okay guys, so what I'm going to do is make 5 videos on this review, and this is video 1, and the first video is going to be only the first page. So the first thing you need to remember are all the reciprocal, quotient, and Pythagorean. These you need to have memorized. You need to have them memorized, okay? So sine is 1 over cosecant, and I do this all the time. I want to spell it out. Cosecant x, and 1 over secant is going to be 1 over cosine of x, and cotangent is 1 over tangent of x. All right, this pauses a second, but that's okay. It'll catch up. Cotangent for the quotient is cosine x over sine x, and tangent is sine over cosine. The first Pythagorean identity with sine squared is sine squared x plus cosine squared x equals 1. 1 plus cotangent squared x equals cosecant squared x, and 1 or tangent squared x plus 1 equals secant squared x. Now, all of these can be rewritten in another way. Like the first one, for instance, can be sine x. Now, be careful. If you want to solve for sine x and replace a sine squared x, it's going to equal 1 minus cosine squared x. So if you'd written it another way, that's fine. And in the same way, you could have solved for cosine squared x. It's equal to 1 minus sine squared x. If you solve for them any other way, and you want to know what sine squared x minus 1 is, then that's going to give you a negative cosine, or cosine squared x minus 1 is a negative sine squared x. You have to be careful solving for these, and you can solve for these two just like we solved for the first one. If you have this committed to memory, that should be an easy thing for you to do. Okay? So going on to the first one, when I do this one, I thought of several ways to do this, and on the key I have it listed both ways. But if I take cotangent, I'm just going to go ahead and distribute first. Cotangent theta, tangent theta, plus cotangent theta times cotangent theta, right? All I did was distribute. Well, this one, 1 over tangent, is the same as cotangent. So that cancels and becomes 1. Plus cotangent squared theta, because I'm multiplying, it's squared. So that becomes plus cotangent squared theta. And oh my gosh, it matches this one. So this is cosecant squared theta. We had to simplify it completely. That's simplified with no fractions. All right, secant on this one is 1 over cosine theta. And 1 minus cosine, as I put right here, 1 minus cosine is cosine squared, times cosine squared theta. This cancels with the squared and leaves me just cosine theta. This one, this becomes 1 from the Pythagorean identity. So this is 1 over cosine squared theta, which 1 over cosine is secant. And it is secant squared. There we go. This one, I got to make sure I'm staying in the frame here. This one, 1 minus sine squared, if you remember, is cosine squared. So this becomes cosine squared theta tangent theta all over cosine theta. Oh my gosh, I have a cosine squared and a cosine. This cancels the power because that was cosine times cosine. All right? So now I'm left with cosine theta times tangent. Well, tangent is sine over cosine. These cancel, giving me just sine theta. here I have tangent is secant. From this rule. All right, and 1 over secant is just equal to cosine squared theta. And I'm done. All right, on the next ones, at the bottom, these are verifying. And you all have gotten a lot better at your verifying. Not 100%, but a lot better. All right, so first one, cotangent is cosine over sine times cosine plus sine. Now I'm working toward cosecant, which means that's a sine. That means I have 1 over sine there, okay? So that means I probably want to get over sine on these and see where I can go to. So I'm adding. I do not have a common denominator. I do have cosine squared x over sine x. But what I don't have is a sine over here. So I need to multiply this side by sine over sine to get that common denominator. And now I'm going to get plus sine squared x over sine. Now, since I have sine, which matches, means I can combine these and get cosine squared x plus sine squared x all over sine of x. Don't cancel. This up here on the top is Pythagorean identity, which goes to 1 over sine x. And 1 over sine x is cosecant x. That matches. We're done. Okay, starting the next one. I'm seeing a couple of things, and I think I'm going to do this. I'm torn. I can factor it out, or I can do something that you guys did on the quiz. This one is actually off of a quiz. This piece, if I go back to this identity, sine squared is 1 minus cosine squared. So if I replace this with 1 minus cosine squared x, I've got negative cosine x in front of this being multiplied and cosine x here. Okay? So what this means is I need to distribute this minus cosine. When you distribute it, it's going to leave you cosine x. This thing just has come down. It hasn't done anything. And this times the first one is minus cosine x. This times the second one, negative times negative, is positive. That's cosine cubed x. And now if I just collect like terms, look what's happening right here. That's an addition subtraction sign. They cancel. This becomes 0. I'm left with cosine cubed x. All right? I didn't do it that way. This is how you all did it, which I really like your method. I don't know if you came up with it on your own or if you said, you know, Google help me, and that's what Google came up with. I'm going to show you the way I did this one originally. I took this one and factored out the cosine x, which left me 1 minus sine squared x. That's factoring these pieces out. Okay? That's this right here. Now, 1 minus sine squared x is cosine squared x, excuse me. Then multiplied by cosine x, which was our original piece, okay, that we factored out. That becomes cosine cubed x. Same answer, both correct. I will take either way on this. Doesn't matter to me. It's actually the exact same amount of work. All right, looking at the one on the bottom, okay, this one. Cotangent squared x plus 1, I know, is cosecant squared x. So I'm going to take, if I take the first step, I'm going to go over here and go cotangent squared x over cosecant squared x. And then cotangent is equal to cosine x over sine x divided by 1 over sine x. Now, if you notice that these are both denominators, they cancel right away. If you don't notice, you can take and rewrite it as keep, change, flip. Cosine x over sine x times sine x over 1. So I flipped. This was keep, change, flip. Okay? The signs cancel. I'm left with cosine x. And I was supposed to get cosine. You know what? Oh, you know what? These were supposed to be squares, which means this is a square, which means that's a square. These are squares that cancel. That's a square that's left. I messed up. Okay? That's the right way. Okay. I dropped a square halfway through. You guys are having an influence on me. Okay. All right, number 9. I'm going to show you what I think is the best way. And I want you to notice that this is a fourth power, which technically means I have secant squared x squared minus 2 secant squared x plus 1. The reason why I've done this like this and just rewrote it, because now if I let n equal to secant squared x, then that means this looks like n squared minus 2n plus 1. And if I factor this and set up a diamond, I'm going to have 1 on top, negative 2 on the bottom, negative 1 over n. So this is n minus 1 times n minus 1, or n minus 1 squared. All right, so if I have an n minus 1 and n is secant squared x, that means what I have is secant squared x minus 1 times secant squared x minus 1. And secant squared x minus 1 is tangent squared x. Which is tangent to the fourth x. And guys, you can't skip steps on these. You can't go, yeah, I just know that this is going to end up here because it says so. You can't do that. You've got to show me every step of the way. All right? Just like in geometry on your steps, you can't just skip to the end. All right? All right, we're done with this one.